He's an associate professor of nutrition at the University of North Carolina, Chapel Hill. Please welcome Dr. Kyle Berger.
Thanks, everyone. It's an interesting question. Just to quickly follow up on the last question, it is really challenging to recruit underrepresented groups. There's a long history of lack of trust with researchers. In nutrition, typically we find women, we tend to over-recruit women because they're more interested, but nevertheless, it's a very homogeneous sample. Here we go. I'm going to tell you right now, even the perfect weight loss diet's not going to work. So there you go. That's my hot take. My clickbait for those online, smash that like button, etc. We'll come back to this. So I'm Kyle Berger. I'm an associate professor at University of North Carolina, Chapel Hill. And I'm the director of the Neuropsychology of Adjusted Behavior Lab, which that's a mouthful. I just spent forever trying to find an acronym that said NIBBLE, because I study eating behavior. We do primarily study eating behavior. And there's a couple reasons I studied nutrition, and one is, as like a 17-year-old, is probably my brightest move ever, is I was like, people need to eat, therefore I'll always have a job. Parents are proud of that one, So the second reason is I so in my soul love how consistent and clear nutrition messaging is to the public. It's so good. I mean, here we have Ansel Keys, hey, eating may not be good for you. Oh, cholesterol's bad. No, wait, cholesterol's good. Hey, what really makes you fat? No, what to eat now? Next year, what to eat now? And we finally just say, eat butter. So that's the end of my talk. We solved it. Go home, have a stick of butter, not margarine. No, but primarily we study food choice and particularly why we overeat, but eating behavior. And like a true academic researcher, I know, I try and take the most simple question and come up with the most complex answer ever, right? That's what we do. We get a lot of money to do it. Thank you, taxpayers. We do study primarily food choice. Primarily, one of the best things that we study a lot of different ways to do this. We use eye tracking technology, so we can see pupil dilation, which is related to serotonin release. So maybe you have an attentional bias to food. We use the Pavlovian condition paradigm, with the bell and the food and the salivation, that kind of thing. But what we're primarily known for is using fMRI. So we can use fMRI to look at brain response while people are actually consuming food, as well as seeing food cues, image not to scale. We have more healthy weight people in the scanner. Nevertheless, but this really helps us out with the study of food reward, because food reward really, really matters. Basically, it's a pleasure you get reward. Primarily, we talk in terms of dopamine, which affects hedonically motivated behaviors. I love doing this to people. You have no idea. So someone in the audience, especially around dinner time, isn't that awesome? I either get lunchtime or dinner time talks, Someone in this audience's pupils just dilated, or at home, they salivated a little. So congratulations, you're a research subject. Thank you. We'll talk about consent later. No, but really, so one of the things I want to talk about with food reward is obesity. So obesity, what you tend to see with obesity, there's these two kind of pathways that you see as far as brain response that you see when you see food cues and actually consuming food. What you see in an individual with obesity, you see this hyperdopaminergic response, attention response, brain response to food cues, like those nice pictures of food, or like if we give a signal that a food is coming, you get hyper response. And then what you see is when you actually receive the food, you see this kind of low dopaminergic response, which seems counterintuitive until you think about tolerance with some substances of abuse, like considering alcohol or those kind of things. You consider cigarette smoking, you see those cues, you're like, oh yeah, no, I want a cigarette, that sounds great. But what my lab has specifically done is we've shown that these are actually an effect of overeating, or eating in general, not necessarily obesity. So why does that matter? Because when you have obesity, you have excess adipose tissue and these kind of things. The excess adipose tissue alters your neuroendocrine functioning in general. And prevention of weight gain is a lot easier than treatment of obesity. So we're trying to curb it off. But the thing that happens is we say, hey, these are a function of overeating. They look like these neural pathways that are similar to these things of substance abuse, and you think that sugar can elicit a greater dopaminergic response than cocaine in animals. But yeah, it's pretty powerful. So we don't really subscribe to the food addiction notion, although something's going on there. But anytime we do a study, we get stuff like this. A couple of these are my favorite. One, I got engaged like 2 weeks ago, so it's super fun. So science explains why ice cream is a great go-to breakup food. We don't need ice cream in the household right now, so I'm very proud of that. But yeah, actually my favorite one, honestly, is your brain doesn't know the difference between ice cream and crack. I mean, I assure you, I was 35. I really worked hard on this study. I did not say that. I promise. All right, so we're going to make a shift. I want you to think about diet as prescription if you're a weight loss diet. So you have, someone says, you need a low carbohydrate diet. Okay, cool. What happens with that? You need to know what carbohydrates are, what foods are with low carbohydrates. You need to be able to access those foods. You need to be able to make those foods. And maybe you like carbohydrates, so now you're fighting against food reward. It's a pain in the butt. You got to do this 3 times a day. Let's think about medication as a prescription. You go to the doctor, you need access to the doctor, you need access to prescription, you go, you grab the prescription, you take the pill 1, 2 a day, you take a shot, you're really only dealing with the side effect. So here's the trick. Roughly 50% adhere to prescriptions, their prescription medication. Yeah, wait, what? Yeah, 50%. 50%. So let's go back to that, even the perfect diet isn't going to work. So if we had the perfect diet, it was as easy as taking a pill. It still would only work in half the population. That's not even getting into metabolics. So what we're talking about here is a lot of the times we intervene on the food level, meaning low carbohydrate and that kind of thing, and metabolic response is super important. However, it doesn't matter unless you put that food in your mouth. So what we were working on now is really working on nudges and reappraisals that teach the person to not actually put the food in the mouth. Some of the examples are, you can change the ease of choosing the things. Maybe you don't walk down that aisle in the grocery store. Maybe you don't keep those foods in your house. Reminding yourself what you know. Repeated practice of, I don't really need that, that's not that healthy, is actually ridiculously effective. It just takes repeated practice and then sometimes social accountability. So in that, I'd just like to close just to remind you that the choice is always yours. I still think it's okay to make matrix references these days, but there you go. Thank you very much.
My pandemic coping was carbs.
Yeah.
All right, Q&A about food information here. We've got first one right here.
Hi, Dr. Berger. Thank you so much for your talk. I totally agree. Behavioral interventions are the way to go. A lot of really great research out of the Peach Lab, another fun name, out of Penn. And I'm curious on the neuronal responses to food. How is the research evolving to kind of integrate all of these various systems of endocrine signaling, gut-brain, microbiome, not even just the vagus nerve, but now like proteins and molecules secreted by the microbiome. And just curious how all it all comes together in understanding human response to food, or would you say the fields are still pretty disparate right now?
You have no idea how much that question hits my soul because I'm working on a review paper right around that now. But Yeah, okay, so some of the things the field is doing is like one of the things that we're doing as far as eating behavior specifically in food decision making, right, is we're doing randomized controlled trials. Yes, I get paid to give people Kool-Aid to drink every day for 3 weeks. That is legitimately my job, right, and see if we can induce those. So there's that end of it. There's an excellent paper by Yvonne Diarojo and Dana Small called Rethinking Food Reward that is actually really focused on the differences between perceptual reward as far as taste and gustatory processes, which is conscious, and then the gut-brain response, which goes directly to the dopaminergic response, which is that conditioning reinforcement processing, which is largely unconscious. So basically, you have these unconscious and conscious pathways that are driving to you, where the unconscious pathways are actually driving you towards food, and those, in this case, would be compulsive-like eating behavior versus these conscious things regarding taste, which will act to select those foods in more of a compulsive type eating behavior. But a ton going on with the gut-brain axis, including the microbiome.
All right, next question coming here from the back of the center aisle.
Hi, Dr. Berger. My question is about intuitive eating. I've been hearing a lot about it, and I struggle with it because my body craves Oreos. So
Yeah.
how does intuitive eating play in that?
Yeah, no, you're not alone. I like Oreos too. Yeah, so there is a lot about, so intuitive eating is going to be based on a lot of interoception, right? So interoception is like feeling body sensations, not necessarily just fullness or, those kind of things. So there is part of the reason that intuitive eating and those kind of interventions can work in some individuals. Now, to be clear, not all interventions are going to work in all individuals. There's a lot of personalized nutrition going on, which is actually improving outcomes. Nevertheless, the cognitive reprisals techniques kind of curb that, curb that initial craving, and basically the sensation typically of fullness on the interoception and the intuitive eating and that kind of thing, it really seems to be effective for individuals. Interestingly enough, a lot of the food reward reinforcement processes that I was talking about travel through the vagal nerve, and one of the ways you measure interoception is trying to do a heartbeat task where you're trying to assess your own heartbeat, and your heartbeat variability is actually related to obesity. So there's a lot there. It's like a really cognitive and physiological connection that actually is running right through your CNS, which ideally in an interoception mindfulness-based, intuitive eating-based intervention can really work in some people.
All right, last question will be coming from the back row here.
Are there mechanisms for hijacking that unconscious reward to incentivize good dietary choices?
So mechanisms from eye tracking, like attentional bias?
So you mentioned the fact that there's an unconscious component to reward, this dopaminergic component of that reward. Is there mechanisms for hijacking that to incentivize eating broccoli instead of eating those Oreos?
Yeah. No, that's a great question. So we're talking about reinforcement-based learning and unlearning and devaluation of outcomes, right? Right. So the mechanism behind that is going to be is similar to any substance abuse or unhealthy, actually just basically habits, right? So way to intervene on that is what you would end up seeing is an obese individual or an individual with that is overeating. What you would see is after you're pairing that reinforcement part with, and it could be represented an opioid response, but also dopaminergic response, is how quickly that devalues when that dopaminergic response is no longer there. So basically, the mechanism, and there's a really interesting work, we've done a randomized controlled trial, but we haven't had the results yet, of a dopamine agonist, in this case trying to increase the receptor viability so it's not constantly going after that, particularly in individuals with the TACA1 allele, which leads to them to have a dopamine D2 receptor compromised dopaminergic functioning, essentially. But yeah, it's going to really fall into that reinforcing structure that's operating at a subconscious level through the dopaminergic system. And so GLP-1 agonists is another example that are proving to be successful, and they tend to help with meal termination relative to meal initiation, so smaller meals in that way. In a similar fashion, operating through dopaminergic regions, reward-related regions.
All right, let's give it up for Dr. Kyle Berger.